recording. Well, I thought we all were.
I'm pretty sure whenever she records in our class, this is Mason going, one, something written.
I was like the same answer.
All right, we are recording.
Um,
So, yes, we should have some secret message embedded in there to see if they actually do watch it. Then we can
Illuminati.
quiz them about it.
You can say things backwards.
All right.
It's like Kappa. My name backwards is way
Okay. So, and this is something. Those of you that are in calculus, this is something that I often do. Actually, pretty much every day. It seems like somebody's done it, or maybe somebody wants to go back and revisit something or whatever. So we record class most days. But anyway, today what we want to do is just spend some time talking about some of the history of computers and where some of the things that have come before. And since I started doing this, there's been a lot of changes just in the last 10 years, 15 years, whatever. And we're not going to probably spend nearly as much time talking about those things because you kind of lived through, some of that anyway. But even sometimes it's hard for me to realize that stuff 20 years ago you weren't living through, or 15 years ago even, and how much things have changed even since the very first iPod. Do you know when the first iPod came out? You know what year that was? Pretty close, about 2001. It's about 2001. Which is not that long ago. And you think about how much that has changed, and I don't know, does anybody even own an iPod anymore, right? Most people have just with their smartphones and things like that. So anyway, where does it all start? Well, most discussions on computer history start here because the first computers were really mechanical aids to do calculations, to help do calculations. And so the earliest mechanical aid, or one of the earliest mechanical aids for doing calculations, the abacus, and it was around for a very, very, very long time. I mean, it's been around as long as 3000 BC, and it was still one of the more commonly used ways of doing calculations clear up until the the Middle Ages, the 1500s, the 1200, whatever the Middle Ages were, somewhere in that time period. Back to the time, up until the time when really the only money that there was really trade, with goods and services, and it was all farming and landowners were the rich people and so forth, and really that was all that was really needed, because the calculations and those kind of things were very simple, and so this was around for a very, very long time, 4,000 to 5,000 years, where this was really the only means of aiding in calculation is the abacus, okay? And then you notice we get to something in the 1600s. Now you start to notice here that the dates on a lot of this stuff, a lot of stuff in the 1600s. Because now you're starting to get into maybe my history's not that great, but the Renaissance, those kind of things like the Galileo, the Newton, a lot of discovery, a lot of science starts to happen. A lot of why does the world work this way? What is going on? A lot of exploration, those kinds of things. And so there's an old saying that necessity is the mother of invention. That things are invented because of a need, because somebody realizes, boy, it'd be nice if we could do this, and they come up with a way of doing it. And so until it was really needed, and so once you got into this time period, then you had these kind of people. Some of these names you may recognize, but they are famous in mathematical kinds of circles. Well, one of these, this was an aid for multiplying. Now, there were a lot of different things out there. This is just a little sampling of different things that were mechanical aids. It was called Napier's bones. These were kind of these rods made of ivory, and you can see they kind of have like multiplication tables. You got like the 6s, the 12, 18, 24, 30, and so forth. So this was something called Napier's bones. I'm not going to quiz you very specifically on exact dates and those kind of things, but just understanding general time periods I think will be important. okay? So the 1600s was kind of a time for these other calculating aids. Okay, the slide rule. Okay, 1630 based on Napier's rules for logarithms. Logarithms, again, is about multiplication. Logarithms are about exponents, and exponents are really just about repeated multiplication. Okay, and so the slide rule kind of came along kind of after the Napier's bones things that we saw there. And the slide rule was used for a long time. Anybody seen the movie Apollo 13? We may have talked about that earlier. In Apollo 13, which happened in the late 60s, you see the engineers at their desk, you know, and they're all frantically doing these calculations, and they're using slide rule, you know. Now, there were calculating devices at that time, types of calculators, adding machines. They were setting at computer terminals. They were very specific computer terminals to do very specific things, but yet they would grab their slide rule because they were good with them and they had worked with them for a long, long time. You can buy apps on, you know, for your iPhone. I've got one on mine. I still don't know how it works, but because I never used a slide, I came along just kind of after that. If you've been in the math office, you might notice up above on the one wall, when you come in, there's this huge one of these, this huge wooden slide that we got from well, it was here when I first came. But that was used for a long, long time for as a mechanical device. Pascal, you may have heard of Pascal. Blaise Pascal was a French mathematician. He had a calculating machine. His father was basically an accountant, and the way this machine worked is these are dials. Think of it like the odometer on your car. So you've got these paper tapes here, this wheel with the digits 0 through 9 going along here, and so it's almost like an old-fashioned phone kind of thing. You could dial in. So if you wanted to put in the number 342, you would dial a 3, a 4, and a 2, and these would go. And then when you went in and dialed again, it would add on. So to add up a bunch of numbers, you would dial them in and keep dialing them in, and those things would just roll over, much like your odometer on your car. Okay? So that was a calculating machine in the 1600s. Leibniz, Gottfried Wilhelm von Leibniz, was a German who's credited with kind of the co-creation of calculus with Isaac Newton. Isaac Newton and Gottfried Leibniz are kind of the co-creators. They both kind of separately discovered various things, came up with various things that eventually came together to be what is calculus now. And that's the way it is with computers in general. There wasn't really one inventor of a computer. There wasn't really one first computer. It was a variety of things all kind of happening at the same time. Just like the iPod wasn't the first MP3 player. There were a lot of MP3 players in the several years before that. They just weren't very good. The iPod was really the first one that people grabbed onto in great numbers because it just worked better. But this one, this had a crank, and it did multiplication, division, addition, subtraction, stuff like that. Okay? All right, then we jump to the 1800s. So there was a time period. So we had the abacus for a long, long time. Then we had the 1600s, kind of that Renaissance time period, a lot of science, those kind of things happening. You had a lot of these mathematicians, scientist types coming up with these things because it aided them in their calculations they needed. You know, Galileo and astronomy and all those kinds of things that were going on during that time period. Then you don't have much happening until the 1800s. Now, in the 1800s, this was a Frenchman, Joseph Jacquard, and this didn't have anything to do with calculating. This was a cloth weaving machine, a loom, and he came up with the idea. And I think I might have another smaller version of this right here. But he came up with the idea of, because the way it worked, the way I understand it anyway, is as you can see, he's got these foot pedals, and he's running some things with his hands there, these rods that would go up and down, and they would need to go up and down in a certain pattern to weave the cloth into whatever the pattern is that they wanted. And it took a very skilled person to be able to run that and get it to have the pattern in the cloth that they wanted it to have. Well, he came up with the idea of basically programming it. And what you see up here at the top are these sheets of metal with holes punched in them. And so what he figured out is that to create a certain pattern, the rods needed to go up and down in a certain way. Certain rods needed to go up at this time, others at this time, and so forth. And so what he did is he just made all the rods go up and down but then they would be stopped by these metal cards, but wherever there was a hole, those rods would go through. And so what he figured out is that he could figure out ahead of time what rods needed to go in, punch these cards, the cards would run through, and so as the rods went up and down, it would create the pattern. And now the person running it didn't need to be skilled at all. They just needed to make the rods go up and down. And so this is essentially kind of the first computer program. I mean, that's basically programming. A set of instructions that causes a certain output to happen, okay? And so this is important because this idea was then borrowed many times over as we got into the development of computers. As a matter of fact, the idea of punch cards is one of the first things we want to talk a lot about here. I've got some examples of some blank cards. We can just pass these around. These were, and I'm going to show you a video here in a second. I've got another thing here that shows an example of one, you know, of a card, and it's got some holes. You can see some holes punched in it. And these were used as input for computers for a long, long time. Okay? So that's why his idea, so that's why Jacquard is important. 1801, first stored program using metal cards. Still in use today, according to that. All right. Then we go into the mid-1800s here a little bit, and we have Charles Babbage. Now, Charles Babbage, if you were going to write something down about Charles Babbage, he might be one of the more important people in the whole history of computers. As a matter of fact, some people might call him the father of computers. He developed, he was an Englishman, he developed these two machines, the first called the difference engine, the second called the analytical engine. And he would get funding from the royalty, the king and the queen. He kind of had a friendship with a lady named Ada Lovelace, who was a member of the royal family. And so he would get funding for these machines, and they never really worked. He never really had the fine enough machinery to make these work. He used punch metal cards for the input. But what's so important about Babbage is he's really the first one that had the idea, that really had this idea of input, like the metal cards, which he took that idea from Jacquard, and then something happening inside, and he used magnetics. There was magnetics in here that he used for the zeros and the ones. This Ada Lovelace, who worked with him, was a mathematician, and she had the idea of the ones and zeros, using the binary number system to store values, and so input, process, output, and then he also had a memory component with the magnetics as well. Okay, using magnetics with the ones and zeros. So he was really the first one to put together this idea of input, process, output, doing calculations, and using this idea of ones and zeros, which really is the basis of every computer we have today, still, to this time. And so that's why sometimes he's kind of given credit as kind of the father of computers, even though he never really built a machine that ever really worked or was sold or did much. But he was kind of ahead of his time because he couldn't get the machinery, the mechanical parts to fulfill his ideas. All right. So then we go to the late 1800s. Now we're into the U.S. Okay, now some things are happening in the U.S. Now think about your American history. What's happening in 1880, around that time period? What's going on in America at that point? The beginnings of the Industrial Revolution a little bit. Okay. What else? What's happening out here in good old Nebraska? When did Nebraska become a state? I feel like this is if one of the history teachers asked my students, what's 4 times 4? Like, it should be a really easy one. I'd feel bad if it didn't. 18, March 1st,
1882.
1867. Okay? All right. So, does anybody watch pro football?
The answer was corn, wasn't
Does anybody watch pro football? Anybody? I hear you guys talking fantasy football. Yeah, that's great. There's a team in San Francisco. There's an NFL team in San Francisco.
30.
They're called the 49. All right? Why are they called the 49? And that was when? It was not 1949. It was 1849. Okay? Okay, and what did that mean? What do you mean the gold rush? What's that mean, the gold rush?
Moved there because the gold.
Okay, where did most people live in the early 1800s? The 13 original colonies, the East Coast. Then we had this thing called the Massachusetts Purchase. Oh, yeah, okay, there we go, good. Everybody was going to shake their head and say, oh, yeah, all right, the Massachusetts Purchase. We had the Louisiana Purchase, right? Right?
Okay.
And we had Lewis and Clark.
I'm actually ready to do it.
I-
Are you ready to do it? Are you serious?
Actually, I believe I'm also related to Meriwether Lewis.
Really? I
That's
Anyway, that's interesting. But Lewis and Clark, right, and the westward expansion, the wagon train, right, heard of the Oregon Trail, right, things like that. In 1880, this was going full bore, right? Now, Herman Hollerith worked for the U.S. Census. What is the U.S. Census? Counting the population, counting the number of people in the United States. Now, when there were 13 colonies all along the East Coast, you know, and it's not like they were calling them up on the phone, right? You know, they were walking door to door, they were keeping track, paper and pencil, they were counting the number of people. Now, why did they need to count the number of people? Why did the government say that there would be a census every 10 years? Okay, one reason would be for taxes, yeah, that's one reason. Think about our system of government.
Representatives.
The House of Representatives, right? That is totally based on population. Every state gets 2 senators, and every state gets a number of representatives based on their population. Iowa, I believe, lost a representative here a few years ago. Nebraska's had 3 for a long time. And that every 10 years after the census, that changes, okay? So that's a very important reason. And then there are a lot of things that have happened more so now than back then. A lot of different government programs and things, some things based on your income, things based on a lot of these things. A lot of that information is gained from the census, okay? And so it's very, very important. Plus, it's in the Constitution. It is the law of the land that the government has to collect this data every 10 years. Well, Herman Hollerith worked for the Census Bureau. And the 1880 census took about 10 years to tabulate. Because what is happening, as we just said earlier, people are moving across the country to the west. They are, it takes the Pony Express and mail takes days and days to get across, right? So the ability to count the people and tabulate and gather that information was getting very, very difficult as America was spreading across from east to west. Okay? And so in 1880, it took 10 years to tabulate that data, which meant now it's already old news, and now we're ready in 1890 to do it all again, and guess what's going to happen? It's going to take longer than 10 years because we've got more people. We also have a little bit of, now a lot of this came later, but a lot of immigration, right? The people from Europe coming over, the Statue of Liberty, right? And Ellis Island, all that. Now, a lot of that was more in the 1900s. And then, but you had this kind of happening as well. So the population is increasing in the country. It's spreading out. It's getting very difficult to do the census. Okay, so now, I found, it was I've always thought, I need to get some video. I've kind of searched around. What I happened this weekend, actually, to be watching a show on C-SPAN. I was just flipping around and I saw something on C-SPAN that sounded kind of interesting, and I clicked on it. And then I thought, and they said, go to cspan.org to check out other videos. I said, hey, that's a great idea. And so all of a sudden I did a little bit of digging here and found some little clips here that maybe tell it better than I can. So let's, and you can see it visually a little more than just listening to the talk. Good. Okay, and why?
This is a replica of a Hollerith census machine. This was a machine designed in 1890 to do the census. The 1880 census took almost 10 years to complete, so the government knew it was in big trouble for the 1890 census because it was going to run out of time before the 1900 census would be due. So a way around this problem was to automate or mechanize the problem. And the way Hollerith solved this was to ask a bunch of questions, the usual questions that census takers ask, and punch the responses into small pieces of cardboard called punch cards. Apparently he got the idea from watching a train conductor punch out the physical characteristics of people in a seat. So apparently train tickets had little sections on them that you would punch out if it was a male or a female in the seat, maybe what their hair color was. So he got the idea, Hollerith that is, of categorizing information in the form of punched holes inside a card. It was the result of a competition by the U.S. Census Bureau. So the Bureau actually did buy these machines once the award was given to Hollerith. And these punch cards could actually be fed into this machine here, under this little tray, and when you close this handle on the tray, wherever there was a hole, there would be a circuit that would be completed, and a corresponding counter would move over one position. So there were little pools of mercury underneath each one of these holes. So when you put the card in and close this press, wherever there was a hole in the card, it would touch a piece of the mole of mercury and make this counter move one position. So at the end of the day, to tabulate all your responses, you just had to read the dials on the machine. Hollerith was a German-American engineer who actually became quite wealthy and based on this invention. And in fact, this invention was the origin for International Business Machine, or IBM. IBM bought most of Hollerith's early patents, and IBM's business for most of the 20th century was in fact based on these punch cards. The way you got information into and out of a computer, an electronic computer, even in the 50s and 60s up to maybe 1980, was by using these mechanical cardboard cards and by feeding thousands and thousands of them into the computer at once to, say, run a program or do something. What we have here is a piece of punch card equipment that IBM designed specifically for the Social Security Administration. In the 1930s, FDR implemented the Social Security Act, and that meant all of a sudden that the government had a really gigantic accounting problem on its hand. How was it going to administer Social Security payments for tens of millions of Americans using old manual methods? And so one of the solutions to this was IBM developed this collator specifically for this problem. And this machine will take two rows of cards and mix them together in a preset pattern, which apparently was an important element in the way that they did their accounting. Some of the first Social Security checks actually were punch cards. And you would tear off a piece of the punch card, and that would be your stub, your receipt. You would get the rest of the punch card to the teller, and they would disperse your money.
Year by year, your wage credits build up. Credits that mean earned security for you and your family. When the time comes, whether it's 30 years from now or tomorrow, those credits will be converted into checks. Checks like these, but with your name on them. Checks which represent the benefits of insurance that is bought and paid for. And every month, these checks are put into envelopes by machines, and they go out to people like this. The amount of your check depends on how much you earn.
So we're looking at a picture of Ida Mae Fuller, who was the first American to receive a Social Security check in January 1940. The first Social Security checks were actually punch cards themselves, and you would tear part of the punch card as a stub, which you would keep yourself, and give the rest of the punch card to your bank teller, who would then give you the cash. But when you deal with punch cards, of course, how do you get the information on the card in the form of holes? Well, you do it by using what's called a key punch. And this is a very early example of a key punch. It has all the letters and the numbers of the alphabet. And every number or letter has a very specific sequence of holes in the card. So this is what basically takes information from human readable form and puts it into machine readable form in the form of holes in punch cards. This is the early computing gallery in Revolution.
Okay, and then I've got, let's go back here, I've got one other small, he talked about a key punch. You saw those mostly ladies working at the desk, and those were data entry folks, and that was a big job. It was just data entry, and they would simply put that into punch cards. And then he does another example. This is just a real short 30-second or so bit here. I just wanted you to see this.
You would have seen this computer running in those areas. Hello, American History TV? Okay. So this is what your program looks like on a punch card.
It's hard to see, but right up there it says "Hello, American History TV," just what he typed in. And so those series
You
of
have seen
holes,
this computer running in those areas.
like right under the H there was a series of holes, and that's what an H was. And so remember we talked about 8 bits and is a byte and 1 character. So an A would be a 0, 1, 1, 0, 0, 0, 1, 1, or whatever, that's an A. Well, the same thing going down there would be 8 rows. I think if you look on this, on these cards, it goes 0, 1, 2, 3, 4, 5. I guess it goes all the way to 9. But and then a series of holes going down, that would represent 1 character. So I missed doing computer programming by punch card by about a year. Because when I was in high school, my first, and I think I told you about this, my computer programming class, we were hooked up by phone line to the state capitol to a computer, and I'll talk more about that here in a little bit. And so we actually typed on a, basically looked like an old typewriter, old-fashioned typewriter with paper coming out of it. But we were hooked up, and we had a cassette tape that we put in there, and it was stored on that cassette tape, our program, and that was our input, and then we would run that. But I went on a field trip to UNL because I was going to go to UNL and major in computer science when I first got out of high school. And so I went on a trip to UNL, a college visit, and we looked at their computer system, and they were using punch cards, and the students would be setting, they would have a computer lab, basically, with a bunch of those machines, very much like what he was typing on right there. And this would have been probably the spring of '81. Okay, so he talked about how that was used a lot up until even 1980. And so students would be sitting there, and that card that he typed, that'd be 1 line of your program. Every card is 1 line of your program. And they would have to be in order. So if you type the wrong letter, that card gets thrown out, you retype the line. Right? So you had to be very careful. So every line of the program was 1 card. And when you would get done, you'd have this stack of cards, and that was your program. And then you would pick that up, and you would walk across the room, and you would hope not to trip and fall and have your cards go flying, because that would be bad. One of the things they always did was use line numbers. They would always put a number at the beginning of every line so that they were easier to put back into order if they had to. And then you would take them over to the card reader machine, and there would be several of those. There would be a lot of these card punch machines. There would be several card reader machines, and you would put it in and hit a button, and boom, it would read the cards. And it would send that information into another room where the computer was, and it would whirl and spinning around and making noise and whatever in there. and then it would send the results to another place, a printer, and it would print out the results of your thing, and then there'd be somebody working back in there, and they would be tearing that off, and then they would put them in a bin. And so you go from the card reader, and you go over by the bin, and you would wait, and you know, might be 5 minutes, whatever, because there'd be other people working. Depending on how many people were working in there at the time. And they would put them in this bin, and you go through the bin and find your output, and you'd see if it worked. And if you had error messages, they'd be on. And then you would figure out your error, and then you go back to your card punch machine, and you type a few new cards and take out the old cards that were wrong and put the new cards in or reorder or whatever you had to do. That was programming. Now, when I went to UNL the next year, they'd got the new system, and they went to terminals and with screens, you know, more like what we're used to, a little bit like what we're used to seeing now. And so I missed it by a year having to do the punch card thing, and I'm glad I did. It wouldn't have been a lot. It was still very similar. We had to type our programs on these machines, and we had this, and then we would run them, and we would send them. It would send it to this computer system. We would not get the output on our screens. Our machines were not computers. They were just terminals. We would type our programs on there. It would be stored and run on the computer, and it would print out to paper. And we would still go over to the bin, and then we would look through, and we would find our printout, and we would look on the paper to see. So it's like in Python, you have the print command to display stuff on the screen. Well, that goes back to those old days. Your output was actually printed on paper back in the day, not displayed on the screen. And so they still use the term print. Okay, so that's a big part. This punch card idea is a big part of computers for a long time. Okay, now we jump ahead. So that's the 1800s. So now we jump ahead to 1940s. Now, what's going on in America, in the world in 1940? World War II. World War II. Without World War II, computers would not have developed nearly as fast as they did. Necessity is the mother of invention. The government needed to be able to do all kinds of intense calculations involving the war. Most notably, firing tables for the artillery. You know, the big guns on the ships are going to fire, you know, into Normandy and so forth, and what angle and for the velocity and what do we need to be able to fire these big guns and things like this. And so the government was throwing a lot of money at university research to develop these calculating devices and so forth. So it greatly sped up the process. Now you notice 1946 the war is basically over, because those things take time. So there were some machines that had been developed, but the ENIAC is really considered the first fully electronic digital computer. Now it really doesn't nearly do, it's not nearly as programmable as what computers are today that we have, okay, and not nearly as powerful. Now this says it contained 18,000 vacuum tubes. We're going to watch a little video clip here again that says there were actually 30,000. University of Pennsylvania is kind of important to remember. Oops. And let's watch this. There's a little. This does a better job of showing some pictures of it. So I think it's just about 4 minutes long.
Here is the floor plan for the ENIAC computer. ENIAC stood for Electronic Numerical Integrator and Computer, and was basically the first large-scale electronic computing system built in the United States. It was quite large. You can see from this model here that it was a large U-shaped, and it was so large people could actually walk into the computer quite easily. We have on loan from the Smithsonian 4 sections, which you can see outlined in blue here. And if you move to your left, you can see the actual sections there. ENIAC had 30,000 vacuum tubes, a little more than that actually. Smaller vacuum tubes on the circuit board. Most important because it showed that large-scale systems could be built out of relatively unreliable parts. These vacuum tubes would tend to burn out quite frequently. So to build a system which could survive and maintain its functionality while these tubes were failing was quite a brilliant design. The designers of ENIAC then went on to form UNIVAC which was a brand new computer that we're going to look at in just a moment. But basically, in this era, computers are still in the area, electronic computers are still laboratory curiosities or owned by the government or very large research type of laboratories that can basically.
I want to comment on one thing there. I forgot to mention, when we're talking about Herman Hollerith in the late 1880s, did you catch that machine became the foundation of a certain company? Remember what he said? IBM. Yeah, he merged with some other people, and they had a company that eventually became IBM. Now, he had a falling out with another one of the head guys from another company named Tom Watson. He was the founding father of IBM, and he so Hollerith wasn't with them when it became IBM, but that was kind of a big deal. He just almost said it. He started to say Remington Rand Corporation, UNIVAC. The two founders, I think they said here later, are Presper Mauchly and Eckert. Mauchly and Eckert were the two professors at University of Pennsylvania that created the ENIAC. Okay, that headed the team that created the ENIAC. And then they went on their own. Now, again, like you said, these were research universities. These were not being made to be sold by companies, okay, until they started this company called UNIVAC. And then it eventually became Remington Rand and so forth. But they really then built the first commercial computer that was to be sold. They'll talk about that here real quick. But I wanted you to make sure you catch that.
Was
those early
designed
companies.
to compute firing tables, which are little booklets essentially that gunners take with them into the field to tell them how to aim and change the settings on their guns to hit their target.
Are people becoming obsolete? A giant electronic brain has started cogitating at the University of Pennsylvania. It's made a vacuum tube, like your radio, and it can add up a column of figures a yard long in a second. It's the world's first electronic computer. Right now, it's solving mathematical problems for the U.S. Army, but who knows? Someday a machine like this may check up on your income tax.
There's a lot of controversy over what is the first computer, and my own answer is that there's really no first one. Parts of what we know as a computer were developed at different times by different people. In one sense, ENIAC was not a computer as we know it today because it didn't store a program, at least until later on in its life. And that is one of the key features of what we understand a computer having to do today. It was paid for by taxpayers. It cost about $487,000 in 1944-45.
ENIAC was 1,000 times faster than any other calculating machine ever built. It could do the work of 20,000 people working by hand. What a desk calculator could do in 20 hours, ENIAC could do in 30 seconds. It could discriminate the sign of a number and compare numbers for equality. It could add, subtract, multiply, divide, and extract square roots. In 1 second, it could add a 5-digit number 5,000 times. ENIAC required a room 30 feet wide and 50 feet long. The 40 panels, side by side, would be 100 feet long. It weighed 30 tons.
The next thing we're going to look at is the UNIVAC 1, a piece of it, a tiny piece of it, which was really one of the earliest. There's another contender in England called the Leo, but the UNIVAC is right up there as one of the earliest commercial computer systems. In other words, the first computer systems that you could actually go out and buy. You didn't have to make them yourself. This was significant because it was showing that there was an actual business case to be made for computing. Before then, computers were built for institutions and governments where money was really not an issue at all. In the business world, of course, that isn't the case. So these two designers, Eckert and Mauchly, who were the main designers of ENIAC, went on to found their own company right after the war. Eckert and Mauchly had met at the University of Pennsylvania at the so-called Moore School of Engineering. Eckert was an electrical engineer and Mauchly was a physicist. And Eckert did all of the circuit design pretty well, and Mauchly helped with some of the programming and some of the applications that could be run on the ENIAC.
When we first started building computers many years ago,
Okay, Okay, so that's kind of the first, what I would still consider, I mean, widely is considered the first electronic computer now in America for sure, and we like to think we were first. But, you know, over in Europe, in England, there was some people as well. But so you saw the vacuum tube circuit board. Here's a person. She was a programmer, a fairly famous. She was actually in the Navy, but that's probably not anybody I would worry about for this. Oh, we talked about a bug in a computer. Supposedly, the story goes, this moth, this programmer, Grace Hopper, found a moth stuck in a relay, which caused a short circuit and caused a malfunction. And so from then on, it became known as finding a bug or debugging a computer. Okay, now here's where, if you want to write something down here, this might be not a bad thing to write down. Typically, we talk about computers in generations, and I may have some questions on the test about the generations of computers. The first generation is roughly in this time period, in the 40s at the start of the war, till about the mid-50s. And this is when you have the vacuum tube. So, it's always been about how do we get the ones and zeros. It started with magnetics. The punch cards also, if there's a punch, that's like a 1. If there's not a punch, that's like a 0. As far as reading that, but internally in the computer, it then became about, first mechanically, it was about magnetics. Then when electricity got involved, then we started, how can we control electricity? Well, the vacuum tubes were the first thing that was used to control that. And the circuitry is inside. There's no air in there. It's vacuum tube to protect the circuitry of those. And so first generation computers were these huge mammoth like the ENIAC we saw. Then they talked about the UNIVAC. Let me see, do I have something on the UNIVAC? No. The UNIVAC was the first one that was like commercially sold. But to be honest, still the people buying them were more the government. The Census Bureau was what bought the very first UNIVAC that Mockley and Eckert sold, went to the Census Bureau, and so you still didn't have wide purchase of this. They were large corporations that may have use of this kind of calculating power. But this lasted up until about the mid-50s. Then we had this thing called the transistor. Now, the transistor won a Nobel Prize. It was developed back in the late 40s, so there is some overlap here. But, of course, once something's developed, by the time it gets into widespread use, that's a whole different story. So we're talking about the machines through the mid-50s were first-generation vacuum tube type computers. Okay? Second generation then started using transistors, starting in the late 1950s. Okay? And so transistors replaced the, and I got one more short little video here. Transistors replaced the vacuum tubes.
My name is Dag Spicer. I'm senior curator at the Computer History Museum. What we're looking at now is a very early computer system. It was a kit, in fact, called the Simon, designed by an insurance actuary who later became kind of a computer guy, computer guru. And it's built completely out of relays. And this is to show you that you can build computers out of many different kinds of components. In this case, it's relays. In the case beside it, we see a piece of the Whirlwind computer from MIT. This uses vacuum tubes to perform the digital logic functions. So in the past, they have used relays, vacuum tubes, transistors, and finally integrated circuits to build computers. Integrated circuits are just billions of transistors, individual transistors put in one little area. That is a model of the very first transistor as it was discovered at Bell Laboratories.
And that's what we just saw.
And that model is from Morgan Sparks, who is one of the very significant Bell Laboratory researchers. A transistor is basically a switch or an amplifier. You can think of it almost as in the case of a switch, as a faucet on your sink. So you have the input, which is the water coming up. You have the tap, and the faucet, which is the switch, and then the output, which is when the water comes out. All you're doing with a transistor is turning the tap on and off. And as a result, it's controlling a large flow of, not of water in this case, but of electrical current. Well, what was before the transistor was the vacuum tube. So the immediate difference was size. Transistor was probably 50 times smaller. It used a lot less power. It didn't have to heat up part of the vacuum tube in order to work, which vacuum tubes actually must do. They must boil electrons off a piece of metal in the bottom of the tube and use that to regulate a current. And so vacuum tubes are also very hot as a result because they're boiling electrons off. So you combine heat, high power, large size, and kind of fragile in situations where they were subject to a lot of, like in military situations, for example, where they don't handle rough handling very well. So transistors sort of came along and solved all those problems. It was much smaller, it used almost no power, it generated almost no heat, and was extremely rugged. Well, nothing has really come after the transistor. The integrated circuits are just transistors. Millions and millions of them put on a single piece of silicon. This is one of the earliest transistor radios. First radios to use transistors.
This was the iPod of the 1960s.
This was really a big deal because the idea of putting a radio in your pocket was pretty extraordinary at the time.
That was a huge deal because, you know, if you watch any old time shows from the 30s and stuff, before TV, people had radios in their house, and that's what they listened to. And they were these great big kind of box type things, and they'd sit around the radio and listen to the radio programs. Well, the reason they were so big is because they were filled with vacuum tubes, right? And that's why they were so big. And so the transistor radio, so you go on a college campus in the 60s and you see people walking around holding their radio up by their ear. Their little transistor radio is a big deal. I mean, you guys like to have your music, and so did teenagers in those days. So this transistor radio was a huge deal. So the transistor, really, that was one of the big uses of that in that time period. So that's second generation transistors. You notice he said that we really have not replaced the transistor. That's really the next big leap we're waiting for, is for something that can run electrical current and control that in a much smaller space. Because what's happening is we go on here, so we talked about the second generation, so mid-50s into the late, mid-60s, we had transistors. So the computers are now getting smaller because they don't need the vacuum tubes, they're getting cheaper, they're getting faster, okay, and they're getting more reliable because they're not overheating, they're not breaking down because of those things, those faults that he mentioned with the vacuum tube. Okay, then we get into integrated circuits. Now, integrated circuits are simply transistors, resistors, capacitors, all integrated together onto a single chip of silicon. All right, and so the third generation operating system, don't worry about that. There we go, third generation. So third generation kind of takes us from the mid-60s to the early to mid-70s. So think about first generation as being till about the mid-50s, 40 to mid-50s. Then you had second generation from the mid-50s to the mid-60s. And then we had third generation kind of from the mid-60s to the mid-70s. All right? And these, and again, things just keep getting smaller because now we take the transistors, and I've got, I'll leave this out here if people want to look at it. I've got some pictures of some transistors. I've got some circuit boards here. I've got some other circuit boards here, some older ones with not much on them, some with this is a really older one with just transistors. And then this has some integrated circuits on it, so we can pass those around maybe a little bit. And so you had this kind of action, again, getting smaller, getting cheaper, getting faster, getting more reliable, okay, as we go to integrated circuits. But that's really just packing more and more transistors onto this little chip. And there's some pictures of some early microprocessors and so forth. We're not going to get into that too much. Okay, and then the fourth generation then is VLSIC, very large scale integrated circuits. In other words, they're just jamming more. So where that kind of cut, where does that make the cut? Probably in the mid-70s. You don't have to write any of those numbers down. But a microchip is very large scale integrated circuit. In other words, it's chips on top of chips. I mean, circuits and more just packing in. Now, you notice he said that with transistors you didn't have the heat issue, but now as you're jamming and packing more and more of this into smaller and smaller space, you do have a heat issue. You know, and that's one of the things with laptops and battery life and iPhones and all that, is that they have to deal with, is putting fans in the computers and trying to deal with the heat as the electricity is going through these small spaces. Just skip right by Doug. All right. So this goes. So look at all those were like 10-year gaps of as a technology increase, and now you're looking at 40-some years where things are getting smaller. We're continuing to press that issue, but at some point there's a little bit of a limit, you know. And how much smaller can we make it? Then also, how small do you want them too? I mean, look at the phones. They were these small things, and all of a sudden now we're getting bigger. You know, the phones are now getting bigger again. You know, because we want to do more with them, and so we want them bigger. So what's the right thing? But you start talking about yeah. Well, that's what I mean. Then you get to the watch, right? Like the iWatch or the Apple Watch or whatever it's called. And you know, so what? You know, the next big thing too is in the medical field, like with implants and so forth, like that, and computer chips and those kind of things. But again, that's where this size issue probably needs to kind of be rectified. Okay, last thing I want to talk about then is personal computers. Okay, so personal computers now come along in the mid to late 70s. Okay, now I was pretty much sitting in your seat about when this was happening. Okay, I graduated high school in 1982. So I was in that middle school into high school when these kind of things were coming out. Now, you don't have to write down these various brands. I don't care about that. Okay, the Altair. This was one. There were a variety of ones. Silicon Valley in California. A lot of this was happening there. Okay, it's kind of where it got its name, and why a lot of the big computer companies and stuff are over on the West Coast, because a lot of this was happening there at that time. Apple Computers, founded in 1977 with Steve Jobs and Steve Wozniak. They were among the first to have a really working, decent model of a personal computer. They gave away a lot of them to schools at very cheap prices, and schools are all about cheap. So that's how Macs, to this day, that's how Macs are. You see them in schools quite a bit. Okay, but in the business world. And now this goes back to Herman Hollerith. IBM was a huge player in business machines in the business world. And they had sales staff and they had connections with the business community and so forth. And so IBM did not jump into personal computers until 1981. IBM looked at personal computers as toys, as gaming things. They did not think that it was beneath them to get into personal computers. Okay? So Apple had it kind of to themselves for about 4 years. Finally, as it started to grow and there started to be, hey, maybe there is a market for personal computers. Maybe people will buy them for their own homes. In the early days, in the late 70s, they were kind of a curiosity. Plus, they were $4,000 or $5,000. People just didn't see a use for them. They couldn't do much. Okay? But then it started to get a little better. And so in 1981, IBM came in. And that's how they got to dominate the business here, because they already had all these connections. And this is how Bill Gates got his start, too. Does anybody know that story? Of how Bill Gates and Microsoft got started? They came to, he was about 19 years old or whatever, him and a couple of his buddies, Steve Ballmer and Paul Allen. They came to Microsoft and they said that we'll write your operating system for your personal computer. And again, you got to realize IBM wasn't that interested. This was a little sideline venture. They were going to do it because it seemed like maybe there might be a market, but they didn't think too much of it. So it was off in this kind of small area of the company. And these guys come in and say, hey, we'll write the operating system for it. We'll like blah, 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 blah. They said, oh, great, fine, go for it. So they did. So the early IBMs ran on MS-DOS, which stood for Microsoft Disk Operating System. And Microsoft owned it. Well, this kind of exploded and people bought it all over the place, and so they made a ton of money, but they also had the rights to sell it to other people. So they sold it to Hewlett-Packard. So pretty soon, Microsoft operating system software was on all of these computers, and which then became Windows and so forth and so on, and then Microsoft became this huge, huge company. Bill Gates got really, really rich. Okay? But that's how, because IBM basically gave it away, the rights to write the operating system for their computers. Now I'm not even sure IBM sells personal computers. I'm not even sure you can buy an IBM computer anymore. Okay? Anyway, some other information there. You know, where do we go from here? You know, what's next? What can we expect? And again, from this point on, you kind of know the history when you start talking about, you know, then what happened with Apple and the desktop computer with Windows and the graphical user interface as that came into play, and what's happened now with the iPods and the iPhones and the tablets, the iPads, and those kind of devices, and it's all just kind of built up from there. I do have some other things up here. We kind of skipped over a little bit. We talked about the punch cards, and then they went to magnetic tape to read the ones and zeros, and then some of my pride and joy, my old floppy disk. This was always kind of cool. All I would have to do is just flip this little thing up like that. Wow, just nicely organized right there. You know, because this is what you had to do. If the early computers, that IBM PC you saw right there was no hard drive. The Apple II, the early Macs, there was no hard drive. And so what happened was, when you ran a program, like this right here says print shell. And so when there would be 2 disk drives, and so I would put my program I wanted to run in one. So like if I wanted to run Microsoft Word, I would put in a Microsoft Word disk over here, and Microsoft Word would make a bunch of noise, Microsoft Word would pop up on the screen. And then in the other side was my DAB disk, like your jump drive, for example. And so I had one of these over here. So whenever I saved, if I wrote a paper, because my roommate bought one of those IBM PCs. So we had one when I was in college, and we typed our papers. So if I had a paper to type, I would type it, and then I would save it on this disk. So when you shut down the computer, everything was gone. There was no hard drive. So everything was saved on these floppy disks. And then, again, feel free to pass some of those around and look at them. And then anybody ever use these? Yeah. And then it kind of went to these, which are basically the same thing except just with a hard plastic case around them. These had more of just a soft side of it. They're just a magnetic circular wheel in there that would spin and it would read there. But these were called floppies. This was actually called a floppy disk too, even though it wasn't real floppy. Inside of it was floppy. So pass some of those around. Here's one of the earlier floppy disks. Okay.
You know, last week it's
What?
it's on YouTube. It's a guy that did something on the nuclear missiles, and apparently he says that our nuclear systems still use those floppy disks.
This wouldn't have been. I never knew anybody who personally, for a personal computer, ever could use one of these. But on larger, business type machines, when on that one part of the video where he was typing on that punch card in the background, there was kind of these machines. Those were kind of the next generation. Those were more your second generation computers. Gotten smaller, but they still were kind of took up a room, for computers and so forth. So anyway. Emma, that's all we got. And if I can find, here it is.
Bye.